Hello dear students, I welcome you all on Gate Wallah English YouTube channel. So guys, today we will discuss a very important part, and you can also say that this is the fundamental part of any type of structure, which is known as the various type of support in the structure, right? Because you know that guys, in our strength of material subject as well as the structure analysis, we need to understand the fundamental point of the support, right? What are the various type of support we have, how many external support reaction should be there, then only we can analyze further our structure like our portal frame or simply supported beam or fixed beam to find out the internal reaction. So as you know that guys, there are a lot of students who are from south side, right, and they demand, sir, please teach this particular subject in English also. So that's why we are bringing a series, basically a fast track course series for the structure part, especially in English language, so that everyone can understand this particular subject also, right? So let me show you the schedule guys completely over here first, then we'll discuss this particular part of the topic, right, which is basically the different type of support in our structure. Okay, let us start this particular thing guys. Okay, so let me quickly show you the fast track course series schedule, or you can say that the titles which we will cover over here. So as you know that guys, in our structure analysis, there are various topics which are important for your GATE examination. And you know that guys, the weightage of this particular subject in the GATE exam is 4 to 5 marks, right? So guys, what is our requirement? Our requirement is at least we can score 3 to 4 marks from this particular subject if we want to cover this subject in a short duration. That's why this particular series I have planned for you guys. Okay, so let me tell you what are the various topics which we will cover over here. Then we'll start our today topic, which is basically the various type of support in the structure part, right? So guys, these are the topic, right? So first one is basically our mastering the static indeterminacy. So you know that guys, there is one topic which is known as indeterminacy part, right? Indeterminacy means what? Later on we will discuss in the first lecture, but let me tell you in a very short term. So guys, basically we have two type of indeterminacy, one is static and second one is kinematic, right? So in this particular schedule, I have covered both the things, whether it is static indeterminacy as well as kinematic indeterminacy. So first we will learn the concept of static one, then we will solve the problem which is related to this one, right? And then again we will understand the concept of kinematic indeterminacy, then we'll solve the problem which is related to the kinematic indeterminacy problem also, right? So guys, this particular topic is important for your GATE examination. So first one is basically static indeterminacy part, then we will understand the top problem which is related to the static indeterminacy also. Okay, the next, or you can say that the third lecture which we have to take, which is basically based upon the kinematic indeterminacy part, in which we will discuss what is basically kinematic indeterminacy, that is basically decay value, how to find it out, whether it is spin jointed structure or rigid jointed structure, whether the member are inextensible, extensible, whether we have braced condition, unbraced condition, all these type of thing we will discuss in detail in our lecture guys. Okay, then we will cover the question part of the kinematic indeterminacy which is related to this. So that means this is the first major portion from where you will get at least 1 to 2 mark question in your GATE examination, which may be related to the static one or kinematic one. That's why this particular part is very important, which is basically our indeterminacy part, right? Indeterminacy part, which is very important. The second portion or second topic which we will take guys, which is basically based upon the analysis of truss. So from analysis of truss, you may find that method of section and method of joint are important, as well as the problem which is related to this, right? And I will tell you how to do these type of problem in a very short duration also. Okay, the next topic which is related to the truss part is again, that is our zero or null force member in the truss, how to find it out. So guys, these two type of concept mostly are in your GATE examination, which is related to the truss part, right? So we'll cover this particular part also in our series. So these are the title which is related to the truss part guys. Okay, then after that, you know that guys, one very major part of your structure analysis, that is basically the ILD, influence line diagram. And from influence line diagram, we'll cover basically the Mueller-Breslau principle, which is mostly asked in your examination, right? We'll understand what is the concept of Mueller-Breslau principle, how we can draw the qualitative ILD from it, right? How to find out the values also. If we know the qualitative ILD, then how we can find out the various values by using Mueller-Breslau principle again. So we'll understand this also, guys. Okay. So understanding and applying the Mueller-Breslau principle, conceptual and the problem solving also. So guys, this is the portion which is related to the influence line diagram, ILD part. Understood? Next one is basically your arches and cables. Arches and cables. So we will discuss the 3-hinge arch analysis as well as the problem which is related to this, and the analysis of cable, how to do the analysis of a cable portion, right? So these two things is also important, from where you can get 1 to 2 mark question which is related to this, right? So guys, this particular chapter is basically our arches and cables. So this particular part we have to also cover it, right? And the last one is basically which is based upon the MDM part, which is displacement method, moment distribution method. And you know that guys, MDM method is most important topic, whether you are giving the GATE examination or ESC examination. No doubt from this particular part of the content, you may find the question in your exam. So that's why guys, I have chosen these type of topic, which is mostly asked in your examination, and it may be possible you are able, means you may find these type of topic in your GATE examination also, guys. And if you cover this particular series completely, then you are able to score at least 3 to 4 mark. It is my guarantee, right? But guys, you need to do some extra effort also. Just after learning the concept, after solving some of the problem which is related to this particular classes, right? So after that, guys, you have to solve the PYQs. You have to solve some other question also, so that you can make your concept more perfect, right? So that is requirement from your side also. Okay. So let us start. Let us start our topic for the today, which is basically the different type of support. Okay, which is basically different type of support. So guys, before understanding the various type of support, we need to discuss, sir, what are the various type of reaction which can be possible in any member, right? Let us suppose this is a 3D member, guys, which we have. Okay, so we need to understand how many reaction can be possible, which can be present in a member. So we need to understand this particular point first, then only we will discuss the various type of support which we have in 2D structure as well as in 3D structure, right? So let us understand the first point, which is various type of reaction which can be there. Okay, so let us understand this, guys. Let us understand this particular thing first. Let us suppose, guys, if you have any doubt, any query, anything, if you want to ask me, you can put your comment in the chat box. Okay, so let us understand this thing, guys. Let us suppose this is our 3D member. Let us consider this is our 3D member. Okay, and you know that, guys, in a 3D member you have basically 3 axes. One is vertical, second one is horizontal, and third one is also horizontal, but that direction is opposite to the first one, right? So let us understand this. Let us consider this is our horizontal axis. This one is one of the vertical axis, like this, and another horizontal axis which we have, which is perpendicular to both of them, right? Guys, let us suppose the length of this particular member is L, and the axis which is along to this length is known as axial axis or longitudinal axis. Please remember this. Whichever axis is along to the length of the member is known as axial axis or longitudinal axis. So this particular axis, let us consider X, and this one is our axial axis. This one is our axial axis or longitudinal axis. Longitudinal axis. Now guys, another axis which we have, which is basically perpendicular to the length of member. You can see here, guys, this is the axis and this one is also our axis, which is basically perpendicular to the length of the member. So can I say that, guys, this one is what? Transverse axis. But this is going in the vertical direction, that's why it is known as vertical transverse axis. vertical transverse axis. This one is what? Basically vertical transverse axis. And this one is horizontal transverse axis. Horizontal transverse axis. Horizontal transverse axis. Now guys, each and every axis will have two type of forces, right? One is basically our linear force and second one is our angular force. So whether you have axial axis or whether you have transverse axis, each and every axis will have two forces, right? Two forces. One is basically linear force and second one is angular force. So guys, let us suppose if you are applying any linear force along to the axial axis or longitudinal axis, then this particular force is nothing as our axial force or longitudinal force, right? Omega, I'm repeating the same thing, just try to understand, listen very carefully, you will understand it is a very basic concept, okay? So I will explain again, there is no problem. Let us listen very carefully. Let us suppose if I apply any force which is along to the longitudinal axis or axial axis, then such type of force is known as axial force, okay? So let us consider if you are applying any linear force along to the axial axis or longitudinal axis, then this particular force is known as axial force. Okay, sir? Now what this particular force is trying to do? It is trying to extend the length of member. It will try to change the length of member. It will try to elongate or compress the length of member. That's why it is known as axial force. Okay? Now next one is basically your transverse force, which is basically known as shear force. Now shear force is trying to cut the length of member in two parts basically. You can see here guys, if I apply a force in the vertical direction like this, then it is trying to cut the member in two parts, right? Let us suppose if I am applying a force like this, then again this particular force is trying to cut the length of member in two parts. That's why such type of force is known as shear force, which is trying to shear off the length of a member, right? So guys, let us consider if we are applying a force along to the vertical transverse axis, then this particular force is known as shear force. Shear force. But the shear force is going in the vertical direction. That's why it is known as vertical shear force. That's why it is known as vertical shear force. Okay, sir. Similarly, let us consider we have a horizontal shear force which is like this, right? And this is also shear force. Why it is shear force? Because again, this type of force is trying to cut the length of member in two parts, right? So can I say that guys, this one is what? This one is basically your horizontal shear force. Horizontal shear force. This one is horizontal shear force. Okay, sir. So these are basically our linear forces which is present in any kind of 3D member, which may be present in any kind of 3D member. So these are basically our linear force. But what about, sir, angular forces? So let us understand that. Okay, let us understand that. If you apply a moment along the longitudinal axis or axial axis, then that particular moment is trying to twist the length of member. That's why that moment is known as twisting moment. Okay, let me show you that. This is the thumb which is trying to show the direction of axis about which we are trying to apply the moment. Okay, let us consider if I apply the moment like this, then this thumb is trying to show us this particular moment is applied about this particular axis, which is basically our axial axis. Okay, so what is happening over here, guys? You can see here this particular length of member is trying to twist, right? So such type of moment is known as twisting moment. So can I say that if I apply a moment about axial axis, then this particular moment, let us consider mx, is known as twisting moment. This one is twisting moment. Okay, sir. And we can represent the axial force by Fx. You can represent the horizontal shear force by Fz. You can represent the vertical shear force by Fy. Right? If this is X, this is Y, and this is Z, then these are the symbolic representation which we can use over here, right? Now similarly, let us suppose if we have a vertical axis, vertical transverse axis, and we are trying to apply the moment about this axis, you can see here guys, then this particular member is trying to bend. This particular member is trying to bend, but this bending will occur on a horizontal plane, right? This particular bending will occur on a horizontal plane. That's why this bending moment is known as what? Horizontal bending moment, not a vertical bending moment. Good evening, Gate Wallah. I welcome you all guys, right? So this particular bending is nothing as our horizontal bending moment. Horizontal bending moment. Horizontal bending moment. Okay, sir. Now similarly guys, let us suppose if we apply a moment about this particular axis, then what will happen? This member is trying to bend like this. Because you are trying to apply the moment like this, so this bending will occur about a, or you can say that on a vertical plane. That's why such type of bending moment is known as vertical bending moment. So we will write here, this is basically mz, and this mz is nothing as basically vertical bending moment. So guys, if you are able to understand these type of reaction or these type of notation which is used basically for a member, then you are able to understand the various type of reaction as well as what are the various type of internal reaction which can be developed in a member, whether it is shear force, whether it is bending moment, whether it is axial force, whether it is horizontal bending moment, whether it is vertical bending moment, like this, right? If you have any doubt guys, please write down in the chat box. I will explain once again if you have any kind of query which is related to this. Please let me know guys, quickly. And this particular session or this particular series which we are going to start guys, okay, I will explain that particular part once again, Gate Wallah, there is no problem. But guys, let me tell you one thing, this particular series is specially designed for those students who demanded for structure part as a fast track course in English language. That's why we are here to deliver you all these content in our upcoming series, right? You know that what are the content which we have covered in our Hindi channel. The same concept, same thing we will cover on English channel also, so that both the type of student will get benefited. Okay, twisting moment ek dafa aur samjha dijiye. Okay, I will explain that particular part once again. Listen very carefully. What is basically twisting moment? Let us suppose this is your member and this is the axial axis or longitudinal axis. Okay, now let us consider if I apply a moment about this particular axis, which is our axial axis or longitudinal axis, then what will happen? Our length of member is trying to get twisted. It is not bending. It is not bending. It is getting twisted. It is getting twisted. That's why such type of moment is known as twisting moment. That's why such type of moment is known as twisting moment. I hope you are able to understand this particular point very well, and all of you are able to understand what are the various type of internal reaction which can be present in a member, right? Now let's start the various type of support which we have in our structure part. So guys, if we talk about the type of support, if we talk about the types of support, if we talk about the types of support, what are the various type of support we have? So basically guys, there are two type of support. One is basically our 2D support, which we are using in a 2D structure or plane structure, right? And the second one is basically the 3D supports, which we will use in a space structure or 3D structure, right? So 2D support or 3D support, both the type of support is useful for us guys, because whenever we are trying to solve the problem of static intimacy or kinematic intimacy, we need to use both the type of concept or both the type of structure, or we need to solve both the type of structure in our structure analysis. That's why you need to understand what are the various type of reaction or support reaction you may find in the support, right? Okay, so let us take the first part, which is basically our 2D support. What are the various 2D support we have? Let us understand that. Okay, so first one is basically the ruler support. First one is ruler support. So how we can represent it, sir? You can draw a circle on a smooth surface, and it is or you can say that it is placed on a smooth surface. So what you will find guys, only one vertical reaction can be possible on this particular support, which is basically the vertical one, like this, right? Or if you want to represent this roller support, you can draw a triangle and below that you have a two circle, and again you may find only one vertical reaction like this, one vertical reaction like this. Now my question is, which type of reaction is this? It is shear force or axial force, or it is bending moment? Please tell me guys quickly in the chat box. Which type of reaction is this? It is axial force or shear force? Please write down. Which type of reaction is this? It is shear force or axial force? Shear force. Okay. Any other student? Venkat says sir, shear force. Okay. Any other student who want to suggest which type of force is this? It is shear force. It is shear force. No guys, it is not shear force. It is not axial force. Until or unless we will not place any member over here, we are not able to define it whether it is shear force or axial force. Because you know that guys, this particular force can be an axial one, this particular force can be a shear force. Let me explain why it is so. Let us suppose if I place the member like this, then please let me know which type of reaction is this. It is shear force or axial force? Please write down. If I place the member like this, then what will happen? This particular force is along to the length of member. Then in such condition, this particular vertical reaction will become axial force, not a shear one. Are you agree with this? Are you agree with this? Please write down. If you place your member like this, then which type of reaction is this? It is axial force, right? Now let us suppose if I place a member like this, then which type of force it will become? If I place the member like this, then which type of reaction is this? It is shear force. Now it is shear force, right? Because this particular reaction is trying to cut the member in two part or length in two part basically. Understood? So guys, without knowing the actual location or actual position of a member, we are not able to define whether this particular external support reaction will behave as a shear force or will behave as a axial force, right? So guys, we should know what is the position of our member basically. On the basis of that, we can define it. Otherwise, not. We can say that this particular reaction is a vertical reaction, nothing else, right? Only simple definition, it is a vertical reaction. Oh, understood? So we can represent it like Fy. We can represent this particular reaction like Fy, right? Because this is a linear force. So we'll use a symbol F, and it is going in a vertical direction. So we'll use a suffix which is Y. So Fy is a reaction over here. Okay. So for roller support, only one external support reaction can be present. Okay, sir. The next one is basically our rocker support. The next one is basically rocker support. Now the question is, sir, what is rocker support? I thought guys, you have seen the rocker chair. How many of you have seen the rocker chair? Most of the horror movie you have find, sir, such type of rocker chair is there, which is moving like this in a room so that they can create a horror scene. Have you seen it? A chair is trying to move like this about a particular surface. It is trying to move like this. Have you seen it? Have you seen it? क्या आप लोगों ने देखा है? Please let me know guys. Have you seen it? Yes, yes. So that particular type of support reaction is basically a rocker support. What is basically the difference between the rocker and the roller? I will explain that guys. But before understanding the difference between these two, we'll understand how to represent it. So guys, what you have to do, you have to draw a triangle. You have to draw a triangle like this and draw a curved surface below this particular triangle, which should be like this. Now, what happened guys? If this particular support is trying to move, it will have some horizontal displacement, but it is a limited one, right? It can move like this and come back to original position. Then like this, then come back to original position. Then like this, then come back to original position. That means in this particular case, or in the rocker support, we have limited horizontal displacement. But in case of roller support, there is no foundation for the horizontal displacement. You can see here, guys, this roller can move infinitely in the horizontal direction. There is no limitation. But in this case, it is limited horizontal displacement. That's why we have a difference between the rocker and the roller support. Okay, so this is basically our rocker support, and in case of rocker support, again we have only one vertical reaction like this. So this is basically the one vertical reaction which is related to the rocker support, and now you are able to understand what is the difference between these two things, right? Okay, sir. Now the next one is basically the free end on a smooth surface. The third type of support is basically free end on a smooth surface. What do you mean by free end on a smooth surface? Guys, you have seen like sofa, chair, or you can have some lakhs of the bed also, right? And all these type of structure will have a free end, right? Let us suppose this is one of the lakh of your chair or your bed. So basically this is a free end which is placed on a smooth surface. And if I place it, then what will happen? It will generate some reaction. But that reaction is only vertical reaction, right? So if you have a free end on a smooth surface, then what will happen? Only one vertical reaction will develop, which should be like this. Now we can define this particular reaction. So can roller support have a moment reaction? No. In case of roller support, it is not possible to bear any kind of moment. It will not resist any moment, right? It will allow any kind of rotation about this particular support, right? So we don't have any kind of moment reaction on this particular type of support. Okay. Okay. Now tell me, guys, in case of free end on a smooth surface, if you have a member like this, then which type of reaction is this? It is axial force or it is shear force? But you can understand, guys, in this particular case, we can define it specifically. We can define it specifically. Please let me know, guys, which type of reaction is this? Which type of reaction is this? Please write down quickly, guys. Please write down. Please write down. Quickly write down. You have a member. It is axial force, Baba. It is axial force. Yes, it is axial force. It is axial force. So this particular reaction is nothing as basically, bacha, axial force always, right? And again, if you have a free end on a smooth surface, it will develop only one reaction, which is vertical reaction, which you can represent as a Fy, or you can say that this is basically, sir, axial force. Okay, sir. Now, guys, let us suppose if we have a member again which is a free end on a rough surface where we will find some friction, right? Where we will find friction. Let me tell you one example. You have seen the ladder. You have seen the ladder, right? You have seen the ladder. Let us suppose this is a wall. This is a wall, and this is a rough surface. This is a rough surface. Some roughness is there, right? So this is basically a rough surface. Rough surface. Okay. And let us consider you have placed the ladder like this. You have placed the ladder like this. Okay, sir. Now what will happen? This is again a free end, but due to this roughness, we'll find there are two reactions which can be developed. One is basically horizontal and second one is vertical reaction, right? So you can understand in this particular case also, if you have a rough surface, and a free end is placed on this rough surface, then we will find two reactions. One is vertical, second is horizontal. Why it is so? Because of some friction. Because of some friction. So in this particular case, if you have a free end on a rough surface, you will find two reactions which can be developed. Sir, is column on a smooth surface and a rough surface? Basically, gate wala, listen first of all. If you have a column, so usually column is to be fixed at the bottom. So will not consider such type of condition. You need to try to understand. I'm giving you very, very simple example so that you can relate it. Like a ladder case, like a free end of your chair or your you can say that the leg of chair or bed or sofa and etc., that is also a free end which is placed on a smooth surface, or you can say that some rough surface. So on the basis of that you can relate it. Otherwise, if we talk about the column, so majorly column is to be fixed at the bottom, otherwise it will get collapse. Okay, usually. Okay, now you are able to understand, sir, what is roller support, what is rocker support, what is free end on a smooth surface, what is our free end on a rough surface. So these type of thing now you are able to understand very well. Okay, let's move to the further part of 2D support. Let us take the next type of 2D support, which is basically our fixed support, So guys, it is very, very simple to understand fixed support, and we are able to represent it also in a very simple manner. Let us suppose this is the member which is clamped or which is fixed like this, and we need to draw some hash line like this so that we can represent it as a fixed. Okay, now in this particular condition there are basically three reactions which can be developed. One is vertical, horizontal and movement, right? So vertical, horizontal and movement. So we can say that this one is Fy, then we have Fx, and then we have Mz. So three reaction will develop over here. In case of fixed support. Okay, sir. The next one is basically our hinge support or pin support. Next one is basically what? Hinge support or pin support. How we can represent it, sir? Guys, you have to draw a triangle like this and draw the hash line like this, or either you can draw a straight line and where you can draw a circle which is a pin, right? And a member is connected to this particular pin like this, right? So either you can represent your pin support or hinge support like this or like this. But in both the cases, you will find there is two external support reaction and both are linear forces which is developed over here. So guys, this is our vertical reaction and a horizontal reaction. Similarly, vertical reaction and a horizontal reaction. So only two reaction can develop in case of hinge support or a pin support. Again, okay, sir. So this is basically our hinge support or pin support. Okay, sir. The next one is basically our vertical guided roller. Vertical guided roller support. Vertical guided roller support. Now, what is vertical guided roller support? Let us understand this. So guys, in case of vertical guided roller support, you can represent it by this symbol or by this symbol. But what is the function of it? Let me explain in detail. Let us consider this is our one box, a box, and there is one member which is connected to this box, and it is basically welded at an angle of 90 degree. This is welded at an angle of 90 degree. That means the angle between this particular box and the member will not get changed. If you apply any kind of load, the angle between this box and the member will not change. Understood? And due to this reason, we'll have one moment reaction which can develop over here. Understood? Second thing, this particular vertical guided roller support or this box can move in vertical downward direction or vertical upward direction infinitely, right? So we can say that, guys, we are allowing the vertical displacement of this particular support. That's why we'll not have any kind of vertical reaction over here. But this box cannot move in a horizontal direction easily because there are some restraining condition over here, right? That's why we'll have a horizontal reaction in this particular case. So you can represent the vertical guided roller support like this or like this. In this case also, the same thing will happen. You are not able to allow to move this particular guiding roller in the horizontal direction. It will not allow any kind of movement, but it can allow the movement in the vertical direction only, right? Similarly, we will have a moment reaction also. So in case of vertical guided roller support, there are two reactions which can be possible. Over here. Understood? Okay, sir. The next one is basically our horizontal guided roller support, bacha. The next one is horizontal guided roller support. So in case of vertical guided roller support, this box move on one of Yes, it can move in the one particular direction. Like in this case, it is vertical one, and in this case, it is a horizontal one. Simple, right? So in this particular condition, you may find horizontal guided roller support is there, which can move in the horizontal direction. The movement of this particular support is allowed in the horizontal direction, or guiding is allowed in the horizontal direction, but it cannot move in the vertical direction. That means there is some restraint which is trying to stop the movement of this particular guided roller in the vertical direction. That means we have one vertical reaction over here. So guys, vertical reaction is present and a movement is present. Similarly over here guys, one vertical reaction and movement is present over here. So in case of horizontal guided roller support, again two external support reaction will develop. Understood? I hope you are able to understand this thing. If you have any query guys, please write down in the chat box quickly. If you have any query, please write down in the chat box quickly. Please write down any query, any question related to this part which we have discussed right now. This particular session is just to have an introduction of your type of support and to tell you what are the upcoming lectures we have in this particular channel or GATE Wallah English YouTube channel, so that you can cover the entire topics or important topics of structure analysis, so that you can score 3 to 4 marks in your GATE examination which is related to the structure part, right? Any query guys, any doubt if you have? Otherwise we will move further. Perfect. Perfect, perfect, perfect. Okay, got it. Okay, let's move further guys. Now the next type of 2D support is basically fixed collar support, or other one is basically hinge collar support. Let us understand what is the difference between these two. Okay, fixed collar support. Let us consider guys, this is a rod. Let us consider this is a rod. This is a rod and this is basically a collar, right? This collar can move horizontally like this, right? Now there are two options. This collar which is connected to one of the member, it may be pin or it may be welded, right? It may be pin or it may be welded. So in our first case where we have fixed collar support, this member is welded with this particular collar. That means the angle between the collar and the member will not change after loading or before loading condition. Okay sir. Now this particular collar can move smoothly on this particular rod guys. So if you try to pull it out, so what will happen? It will not allow it. Why? Because we have one vertical reaction. So in this particular case, we will find one vertical reaction will develop in the upward direction. Second one is the movement part. You can see here guys, this member will not change its angle with respect to the collar. That's why a movement reaction will develop over here. So two reaction will develop in case of fixed collar support. But mostly such type of support is to be used in case of mechanical engineering part. Mostly guys, in our civil engineering, we will find fixed support, pin support, roller support and etc. Right? The next one is basically the hinge collar support. Now what is hinge collar support? In previous case, we have welded this particular member with the collar, but in this particular case, we are trying to pin it with respect to collar. But in this particular condition, it is trying to change its angle with respect to the collar guys. You can see here, right now this is angle theta. This angle is theta. If you move the collar anywhere, this particular member can change its angle with respect to this particular point easily. It can change its angle with respect to this particular point easily, right? So we can say that guys, in this particular condition, the movement reaction will not be there. Movement reaction will not be there. Only one reaction can develop, and that is basically vertical reaction. Only one vertical reaction will develop. Clear? So in case of hinge collar support, we have one reaction only. In case of hinge collar support, only one reaction will be there. Now guys, I hope you are able to understand completely all the 10 type of 2D support which we have discussed. 10 type of 2D support. Roller, rocker, free end on a smooth surface, free end on a rough surface, fixed support, hinge support, vertical guided roller, horizontal guided roller, fixed collar support, hinge collar support, and all 10 type of 2D support which we have discussed. I hope you are able to understand it very well. Okay. Now let's understand the 3D support, guys, which is the last part of this particular lecture. Okay. 3D support. So first one is 3D roller support. So there are two possibility. You have seen this cooler stand, or you have seen the car also, guys. So both the type of wheels or both the type of roller condition is a 3D roller condition. So let us take the first one, which is basically our cooler stand. So in case of cooler stand, guys, we will find only one reaction will develop at a roller, and this particular reaction is a vertical reaction, right? So in case of 3D roller support, you may find one vertical reaction can be possible. But there is another aspect, guys. If you have a car wheel, so in case of car wheel, what will happen? There are two reaction can be developed in this particular case. Let me explain why it is so. One is vertical, which is but always, guys, you can understand why it is developed. If you apply any kind of vertical loading in the downward direction, it will generate some vertical reaction in the upward direction, right? Now let us suppose a car is standing in a neutral condition, right? And I'm trying to apply the force like this. I'm trying to apply the force like this, right? From the side, not from the back side, from the side, right? So what will happen? It will generate some reaction which is trying to oppose my force, and that particular reaction is nothing as our friction force, right? So in case of 3D car wheel, or you can say that the wheel of a car, basically you will find two reaction which can be developed over here, right? So there are two possibility in case of 3D roller support. You may find one reaction can be there or two reaction can be there. But in our structure analysis, what we have to do in our theory of structure or in our structure analysis, we will consider only one external support reaction will develop in case of 3D roller support. Clear? In case of 3D roller support. Understood? Next one is 3D hinge support. So in case of 3D hinge support, you know that, guys, hinge support is not capable to take or to bear any kind of moment, or it will not resist any kind of moment. It will only resist the linear forces. But now in this particular case, it is a 3D hinge support or 3D pin support. It will resist all three linear forces which is present in a member, right? So you can see here, guys, vertical reaction is there, horizontal reaction is there, and another horizontal reaction is there. That means Fy, Fz and Fx, all three linear forces will be resisted by this particular support, and that's why it is 3D pin support or 3D hinge support. And the last one is, which is basically fixed support or built-in support. Fixed support or built-in support. This is 3D built-in support or 3D fixed support, you can say that. In this particular case, all reaction will develop 3 linear and 3 angular, right? So you may have Fy, you may have Fx, you may have Fz also. Similarly, you may find My, you may find Mx, you may find Mz also, right? So all 6 reaction will develop in this particular case. Understood? Crystal clear or not? Please write down, guys, in the chat box quickly. Are you able to understand all the type of support which we have discussed in our class today? It is 2D as well as 3D. Please let me know, guys. Crystal clear? Very nice. And this is the short introduction of your various type of support which is present in a structure, which you are using in case of strength of material, in case of structure analysis, in case of RCC also, right? So guys, basically this lecture is just for the introduction part, but the major thing is, which is coming from tomorrow, you know that, guys, from tomorrow onwards we'll start this particular series and we'll complete it on our English YouTube channel also, right? So guys, on 26th of August we'll take this particular first lecture, which is basically related to the static indeterminacy part, and again the timing will be 6 p.m. okay, again the timing will be 6 p.m. So kindly join it tomorrow, right? And you are able to understand, if you are able to understand all these topics, you are able to solve the problem which is related to this also, right? If you have any query, any doubt, guys, please let me know. Until that, guys, you can take the snapshot of this particular series or this particular course also, and which we will cover on English YouTube channel also, guys. Okay, you can take the screenshot of it. As well as if you want this particular PDF, you can get it. The link which is below available, which is available below this particular video, or either you can join my Telegram, guys, where you can find this particular PDF directly also. Okay, where you can find this particular PDF directly. So you can join this particular Telegram also, guys, Krishna Yadav sir PW. You can search it on the Telegram where you will find this particular channel, and I will share you the link of the upcoming classes as well as this particular PDF also, as well as you can ask any doubt which is related to your subjects like structure, environment, RCC, etc. Okay, so any query, any doubt, guys, if you have, please write down quickly. Please write down quickly, guys. Otherwise, we'll close the lecture and leave tomorrow, in which we'll start our first lecture of the series or course, which is basically the static indeterminacy part. Any doubt, any query, guys, if you have, please let me know quickly. No doubt, sir. Okay, fine. Crystal clear? Venkat, Gatewala, and any other student, guys, those who are live over here, please let me know. Sir, will there any be EE fast track course in future? Venkat, we will have one session which is related to the environmental engineering, which will be there on Gatewala Hindi YouTube channel on upcoming Saturday, right? I will plan it. I will tell you about like that title. I will tell you in Hindi, right? Environmental engineering का जो टाइटल है, हाँ, environmental engineering की कहानी, मतलब environment की कहानी मेरी जुबानी. That is the title of that particular lecture, and you will understand what is the relation between all the topics of the environmental engineering in detail, and I will tell you about that. If it is required on English YouTube channel also, I will take that particular session on English YouTube also, right? Okay, please let me know if you have any requirement for such type of thing. I will take that also, no problem. But on upcoming Sunday, we will take this particular session, Environment ki kahani meri zubani, on Hindi YouTube channel, guys, at 6 p.m. I am planning that, and if it is confirmed, then I will share you the link also on my Telegram. And definitely you will enjoy that particular session. Clear? Okay. Thank you so much, Venkat. Thank you so much. Thank you so much. Thank you, Gatewala. Definitely, I will help you guys. Whatever topics, whatever things which is required as per your gate, whatever suggestion or whatever guidance you need from my side, guys, I will definitely give you so that you can achieve your dream, and that is my only goal, right? As a teacher. Okay. Okay, guys. So let's close the lecture and let's meet tomorrow at 6 p.m. again, where we will start our first lecture of this particular series, which is basically the static indeterminacy part, and we'll discuss it in detail and we'll solve each and every different type of question. I'm also, yes, I remember you guys. I remember you, Gatewala. I remember you. मैं नाम नहीं भूलता, मैं कभी भी भूलता नहीं हूँ अपने students को. I never forget my student. Okay, so I always remember, right? Okay, chalo bacha. Okay, thank you so much, guys. Let's close it. Let's meet tomorrow at 6 p.m. where we'll start our first part of the structure, which is basically the static indeterminacy. Thank you, guys. Thank you so much for joining the session. Let's meet tomorrow. Bye bye and take care, guys. Thank you.